Hello and welcome to R&D Mathematics. Today we are going to talk about again graphing techniques. Graphing techniques. Last technique that stretching and compressing. Stretching and compressing. Now it can be vertical stretch, vertical compress, or horizontal stretch, horizontal compress. So four things. Little bit complicated, but let me break it down. So again, let C be a positive constant. Now, first let's start with the vertical stretching and compressing. So vertical. So graph of C times f of x is a vertical stretch if C is greater than 1. Right, now let's see an example before we continue. For example, let's say a simple example over here. Let's say g of x equal 3x squared. Our base function is x squared. Now because of this 3, what will happen, just to explain this, I will draw this. I recommend when you're doing, you have to draw it in, it's better to draw it in a separate diagram, but since this is just for the explanation, if this is x squared, now this 3 will stretch. That means it will vertically stretch. For example, whatever happened at 1, let's say g of 1, not g of 1, let me call this guy fx is x squared. So f of 1 is 1 squared, which is 1, right? But g of 1 is 3 times 1 squared, which is 3. So that value is stretched 3 times. So every single value on this graph will be multiplied by a factor 3. So this will go somewhere here. Because of that, our graph will vertically stretch. So remember, whenever there is a positive constant appearing, that constant has to be greater than 1. If that is the case, it will, your graph will be skinny graph. It will be stretched. And the next case, if C is between 0 and 1, then it is a vertical compression. Now let's take for example, let's take h of x 1/3 x squared. Now again, our base function is x squared. Now in this case, let me draw it in the same graph using white color. Now if you look at h of 1, it is 1/3 of 1 squared. So it is just 1/3. So now what has happened is this value right here, this value 1, now it's 1/3 somewhere here. So your graph will look like this, more fat. So it has compressed. So you don't need to remember stretching and compressing if you can remember the idea. Normally that's how I do it. So simple as that. So this form will go with vertical, and depending on this case, if it is greater than 1, it's stretching, it gets skinny, and if it is in between 0 and 1, it gets more fat. And you can guess for the horizontal case what's going to happen. So for horizontal case is this. So earlier it was C of f of x. Remember, let me show you. See, C of f of x. Now what is going to happen is, this is exactly what we have been doing. So in front of the function and inside the function. So the change is now happening to the variable. So now for horizontal, it's f of c of x. So if this happens, again, if c is greater than 1, what will happen? And if c is between 0 and what will happen? Can you think? Can you think? This is a little bit counterintuitive. Actually, if this happens, this time it's horizontal stretch. And if this happens, it's horizontal compression. Now let's see an example, then you'll understand. Now, before I give you an example, see, let me take this. Let's say this is our base function. Let's say we are doing a vertical stretch. See, vertically stretching your. Can you guys understand vertical stretch is same as horizontal compress? If I compress this way, it's going to look, so that's why, see, for he's here, look at here, horizontal compression, and for vertical stretch, see, c is greater than 1, even though the changes happen into variable and function separately, there is a connection between these two. So it's enough to use one, but sometimes it becomes handy when you remember all of these things. Now let's see an example. Let's say g of x is square root 3x. Now our base function, let's say f of x is root x, and it looks like this. Now according to this theory, see, the 3 like c is greater than 1 and it's inside our function. So here root base function is root x, and we are applying this theory, this part right here. So it will be horizontal compression, right? So horizontal compression means you kind of do this. So ultimately what will happen is it will go a little bit up and do that. Does that make sense? Now let me explain this same thing. Now, root 3x, g of x, root 3. See, I can write this as root 3 times root x. Now this belongs to, because root 3 is a positive constant, it looks like this one right here in our earlier case. So root 3, that number is 1.732 something, so it's greater than that, so it's a vertical stretch. Again, see, vertical stretch. So you get this guy right here. So that's why I told you vertical stretch is a horizontal compression. Vertical compression is a horizontal stretch. So any question you can address either using vertical or horizontal. But sometimes some problems, one way may be easier than the other one. Now let me show you another example. How about this? Let's say f of x equal 9x squared. Now our base function x squared, right? Our base function is x squared. And if I am using, let me show you vertical, this part right here, this theory part, c of f of x, and c is greater than 1, it is 9. So it's a vertical stretch by a factor 9. So what will happen is your graph will become, what, let me draw the original graph with dotted line. So your graph will become much thinner, right? Because you vertically stretch it. Now you can address the same thing as in a different way. 9 is a nice number, so 3x everything squared. Now what I am doing is, let me show you the previous slide. Now I am going with horizontal, see? So I am doing a change to my variable. Can you guys understand that? Because form of my base function is, let me start, my base function x squared now. So the form of that function is something squared, and in front of my variable right here, I am putting a number 3 here. So now it's a horizontal thing. So horizontal compression. So you compress. So horizontally compress by a factor 3. So if, let me draw my original function. So when you compress this guy, again it's going to look like this. So I hope now you understand what I was saying. So you can use either verticality or horizontality. Anyway, now in our, but again, remembering both is really, really helpful. In my next video, we are going to combine all these techniques and do a lot of transformations. Thank you.